So I'm preparing to talk us through experiment 6. There is information in the lab, but it's a lot about how we balance these equations, which I talked about in the lecture part. So that's what you're expected to do with this. Now, I am perfectly willing to go through each and every one of these with you on an individual basis if you contact me. I think it is important that you practice this on your own because I could do it until I'm blue in the face, but that isn't going to help you do it. You need the practice. So, while I said that I was going to go through this in detail, I think what I'm going to do instead is point out to you that a couple of these have basic solution. So this one is basic solution, number 4. Number 5 is also basic. And then 9 and 10 are both basic. Now, again, I would like to see you do these in your lab. And then if you copy that and turn that in, that's all I need for the lab summary. Really, I can't force you to do that. So that's entirely up to you. But that would be my preference for how you do that. I had a thought. I don't remember where it went. So sorry. I'm just looking at these equations because I think there's something. Okay. So I think you should do this. Now, if you do this and you have problems with any of it, please let me know. Like I said, I'm more than happy to walk through this with you individually. I have had students come to me and we have done all of them together. That is perfectly fine. It is important to me that you understand, but it's also important to me that you try. You need to try because I am not going to be able to do this for you on a test, and you will get asked to do this on a test. So it is important that you're able to do this on your own. Okay. So that's all I'm going to say about this. That is the only thing that you need to do for that part of experiment 6 is balance those. There is a post that goes with experiment 6. Let me find it. And this post lab wants you to define can oxidation occur without reduction? Can it happen? And explain. What is the oxidation number for chlorine in each of these species that are listed? So find the value for the chlorine. Sodium chloride solution reacts with hydrogen in a basic solution to produce nitrogen monoxide and chlorine gas. The net ionic equation is as follows. You're asked to balance it. Remember, it's in basic solution. It asks you what is reduced, what's the reducing agent, so what caused the reduction, how many electrons are transferred, and how many moles of water when this is balanced, how many moles of water. Okay, that is all that's in the post lab. And remember what I call oxidation reduction. It's redox. There's a reason that I gave for why it's called that. That should help you with number 1. As far as number 2 goes, I'm going to walk through one of these with you so that we can see what needs to be done here. And I'm not going to do it for NaCl because I think that one's pretty easy. But when we talk about the HCl, I know that H, when it's bound to nonmetals, is plus. So H is +1. Oxygen is always -2. So if I add those two together, I still have a -1. But overall, this thing needs to be a 0 charge because it's net neutral. So that means that the Cl has to be a +1 too, as well. Also, +1. Okay. So that's what you need to do, is determine what is the oxidation number for chlorine in each of those species. Okay, I'm not going to do it anymore. I'll let you do that. Sodium chloride solution reacts with hydrogen. I will give you the two half reactions, which shouldn't be that bad. But N2H4 goes to NO, and then ClO2 minus goes to Cl2. So those are your two half reactions. That's what you need to balance. Okay. Make sure that you've gotten that done. Identify what's reduced. Okay. Gain electrons reduced. So remember that that's gain electrons reduced. That's the one you're looking for. What's the reducing agent? What was oxidized? So the one that's the LEO. How many electrons? Remember when it's balanced, how many electrons were there? And then how many moles of water are produced? You'll find water on one side of, or the other of this equation. Just say what the stoichiometry is. Okay. Again, if you run into problems with this, let me know. But it shouldn't be that bad. Okay. So that's everything I have to say about experiment 6. That should be everything you need. Now, again, if you have any questions, comments, problems whatsoever, let me know. Okay. This is not going to be due for, I think it's over a week now. So we have time to walk through this together if you feel it's necessary. Once you've watched the redox reaction, or the redox lecture, you can do this. Okay, so that's lecture 7 goes with this. You should be able to handle this once you've done that. If you run into problems of any kind, let me know. I'm going to stop sharing at this point, and I'm going to close this out, and I'll come back and talk to you about experiment 7 in just a couple of minutes. Thanks, guys.